Hello, friends. Do you think that the constant that govern our universe aren't so constant after all? Today, we dive into this mind bending world of the fundamental physics as we explore further the speed of light, Planck's constant, and the gravitational constant that we think are truly fixed. From the fine tuning of the cosmos to the possibility of a changing universe, we will challenge what we know about the very fabric of the reality. Let's go. Hey everyone, and welcome. Grab a cup of coffee and get comfortable because today we are diving into one of the most mind bending questions in all of the science. Are the fundamental constant of the universe are truly constant? It sounds like a ridiculous question, right? Constants are by definition unchanging. The speed of light, the gravitational constant, the Planck's constant, these are the bedrock of our physical laws. They are the numbers we plug into our equations to predict everything from the orbit of the planet to the behavior of the subatomic particle. But what if they are not? What if somewhere out there in the vastness of the space and time, these numbers are subtly or even dramatically different? This isn't just a philosophical exercise. It's a deep and serious question that get to the very heart of what we know about the reality. It forces us to confront the possibility that the universe we see isn't only possible universe, and the laws we have discovered might just be a local rules, not the universal truth at all. To start, let's make sure we are all on the same page. What are these fundamental constants that we are talking about today? At the top of the list is c, the speed of light in a vacuum. It's a cosmic speed limit, the fastest anything can travel. It's not about light, it's a fundamental part of the Einstein theory of relativity. Next, we have g, capital G, the gravitational constant. This is a number that tells us the strength of gravity, and that is what makes Earth orbit the Sun and hold the galaxies together. Then there is h, the Planck's constant. This is a key player in quantum mechanics. It relates a particle's energy to its frequency and is central to our understanding of the subatomic world. There are others like the elementary charge of an electron or the mass of a proton, but for today we'll focus on these big three. These constants are special because they aren't derived from anything else. They are just there. They are the parameter that defines our universe. So why would anyone even question their consistency? The first and the most compelling reason comes from a something called the fine tuning problem. Imagine a cosmic dial. The value of each fundamental constant is set on this dial. What we have discovered is that if you were to change any of these numbers by even a tiny amount, the universe as we know it would cease to exist. Take the strength of gravity, which is capital G. If it was slightly weaker, matter would never have been able to clump together to form stars and galaxies. If it was slightly stronger, universe would have collapsed back into itself long ago. It's the same for other constant. If the speed of light was little different, the physics of the nuclear reaction inside the star wouldn't work and there will be no heavy elements. If the Planck's constant were off, atom might not be stable and matter as we know it would not even exist. It's an important and almost impossible, unlikely coincidence. The universe seems to be, strictly balanced on a knife's edge of existence. This has led to some to ask if this just an accident or this is a reason. There is a reason for it. This fine tuning problem lead to a couple of mind boggling possibilities. The The first possibility is that the constants aren't truly fundamental. They are just what we have measured them to be right now. In our little corner of the universe, what if they have changed over the cosmic time frame? One of the most famous people to consider this was the physicist Paul Dirac. He wondered if the gravity, being the weakest of the fundamental forces, was getting even weaker over cosmic time frame. Scientists have been trying to test this idea for decades. They look for subtle changes in the constant by observing distant objects. For example, they look at the light from ancient quasars, which traveled for billions of years to reach us. The light from these quasars carry a signature of the physics of that distant time and place. By analyzing that light, we can look for a subtle difference in the constants compared to what we measure today. So far, these measurements have been incredibly precise, haven't found any significant change so far. But the search isn't over yet. Other theories suggest that the constant might change depending on the local environment, like near a massive black hole or in the early moment in just after the Big Bang. Some theory even propose that these constants are connected to the fifth force that permeates throughout the cosmos that we have yet to be identify this the new elusive force. So what is other explanation for the fine tuning problem? If the constants aren't changing, why are they so perfectly set? This leads us to one of the most speculative but fascinating idea in all of cosmology, and that is multiverse. The multiverse hypothesis suggests that our universe is just one of the infinite number of universes. In each of these other universes, the fundamental constants might have different values. In most of these universes, the constant would be set like a wrong value, leading to universe that collapse instantly, or just as formless soup of particles, or are simply sterile and boring. But in some universe, the constant would happen to be just right, allowing for a formation of stars, galaxies, and life. And because we are here, we must be, there must be a definition be in one of those universe. It's a bit like winning the lottery. You don't do anything special. You just happen to be in the right place at the right time. The idea is controversial. It's difficult, if not impossible, to test directly. But it would provide a compelling explanation for the fine tuning problem without having to resort to mystical or supernatural explanation for why our universe seems so special. So, where does this leave us now? Are the fundamental constants truly fundamental? The current scientific evidence suggests they are. The incredible precision of our measurements across vast cosmic distances and time points to a universe governed by a single unchanging set of rules. But the question remains, the fine tuning problem is a real puzzle, and the possibility of changing cosmos or a multiverse continues to inspire new theories and new experiments. Ultimately, this is one of the most beautiful things about science. The answers we have are solid, but the questions we are asking are even more profound. And with every new discovery, we get a little closer to understanding the true nature of reality. So, friends, what do you think about this subject? Do you have any opinion or you have any questions? Please leave them in the comment section below. Thank you for joining me today, and I will see you again in the next one.